programming tips and tricks and actually make a full game. By the way, I will be holding this talk in English. I hope that's okay with everyone. Jeg skal holde foredraget på engelsk. Håper at det ikke er et problem. Yeah. So you want to make video games. And if you want to follow this presentation yourself on your computer, go to folk.uu.no/gamedev/srodk/gamedev/intro. There will also be links a few times that you might be useful. So if you open up the presentation yourself, yeah, and you can follow along. I'm gonna wait a bit, so those who want have the time to go to this website. Folk, yeah, folk. Yeah. There you go. And that'll be the same as this presentation that I'm holding here. Alright, so I'm just gonna continue. And like, if you just go to folk.uu.no/srodk, you can navigate yourself to game.intro. If not, that might make it a bit easier. Yeah, alright. Now I'm gonna start off presenting why I'm holding this talk and what inspired me to have this presentation. And that is because of this one situation that I've found myself in very many times. I'm talking with someone and about programming mostly, and they ask me what I'm programming, and I will mention, among other things, that I do some game development as a hobby. And they always respond with, "Oh my, you make video games? That's awesome. I'd like to make video games someday." And you know, I always wonder, well, why aren't you? You could make video games since you already know some programming. But I often get the response, "Oh no, I can't make video games. I only know how to do for loops and if statements and maybe some multiplication and other stuff. I don't know how to make video games." But I think this is a very big fallacy. It's a mistake, because in fact, for loops and if statements and functions and classes, that is everything you need. If you know those four things, you can make video games, no problem. So yeah, that's this. You only need the basic level of programming to make video games, and then experience. That's basically it. So like, this misunderstanding of when they say they can't make video games is oftentimes because they think too abstract about what a video game is. If you ask them what a video game is, they'll answer it's like levels and enemies and scores and unlockables and all those kind of things, which are very abstract concepts that you shouldn't think of that way when you're programming. When you're programming, these are all simple things. You know, an enemy is when you have one type of enemy and you have many enemies of that type. Well, that's the same as having one class that is the enemy, and then you have instances of that class, which are the specific enemies around the level and stuff like that. And you can reduce it to a much simpler level when you think about it. And then when you get down to the basic level, the video game is really a very simple thing. It's interaction. Interaction is what sets video games apart from other media. It's what makes you, it's like you can't interact with movies, but with games you have this level of interaction. And what is interaction? Well, it's inputs and outputs. Basically, the thing that makes video games different from other media is that the player can talk with the game in a sense. It can send inputs to the game and get outputs. And inputs are basically any message that the player sends from the player to the game. So stuff like keyboard. Yeah, should we close the door? I don't know. Yeah, Krista, thank you. Yeah. So like keyboard buttons, and if you're on a console, you might have a gamepad, mouse, and even like on the iPod and other such systems, you have stuff like voice commands, maybe accelerometers on your phone, touch, and all that kind of stuff. This is any message that is being sent from the player to the game. And output is the opposite. It's any message that is sent from the game to the player. This is stuff like graphics and sounds, like vibration on your gamepad and other such things. And when you think about it on a simple level, and now I forgot to include a slide for this, I might have to, just like show you. When you think about it in a simple level, it's what you have is that you have this input going into the system, and you have the system which is just basic programming. You know, you process that information, the input. You do all kinds of maths and stuff with it, and then you have you return an output, and that is the entirety. So basically, we know how to do basic functions, classes, and loops, but we still don't know how to achieve interaction. I mean, yes, we need the inputs and then producing the outputs, but how do we get the inputs and how do we produce the outputs? That's like the basic problem about making video games. It's okay, I know how to do the middle part once I have the information and you know how to, but how do I get an input and how do I give an output? And the answer is actually very simple, because yeah, all we need is a tool that can take these basic things, functions, classes, and loops, and other such stuff, and like turn it into inputs and graphics and sounds and all that stuff. And as it turns out, there are many such tools available that do this for us. They simplify the input and output system. So among them, video game frameworks are the important part, and these are all links, by the way. If you go to the talk, there are 6 examples of various video game frameworks, and these are tools that allow you to get the inputs that the player is using very easily, and so on. These are designed specifically to do this, to basically create a very easy abstraction layer so that you can get the input and give output to the player. Among these that I put up here is Love2D. This is my personal favorite and the one I will be showing off, which is programmable in Lua. But there are, you know, game frameworks for all kinds of languages, all kinds of programming styles. You know, some of these are more higher level, so you do less programming yourself. But some others like SDL is very low level. It gives you the very basic input and output stuff, and you have to do a lot of programming yourself. And you know, it all comes down to preference. Some people like to program a lot themselves. Some people would like a lot of the stuff to be done by the framework. And most of these are 2D, by the way. Unity over here can do 3D, and Unreal Engine is another one that can do 3D if that is what you want, and so on. And basically, you just have to find the framework that suits you. You can try them out and figure out how it works. So right now, I'm going to just show you an example of how one would go about, you know, making a game using one of these engines. I'll be using the Love framework, and like I'm just gonna follow the link first and show you around a bit of how one might use such a framework. If I go to this link, this is the website for Love2D. Oh, it's very bright on the screen, on the projector for some reason. I hope it's readable. And you can download it here. The good thing about Love is that it can run on Windows, Mac, and Linux, also on Android and iOS, but that's not officially supported quite yet. And you only need to program it once, and then it can run on all platforms. To download it, you just like download one of these, whichever one you want. A quick warning though, if you're using Linux, you might be better off just getting the source and compiling it yourself. If you get it from one of the package managers, they might be outdated, you never know. Make sure that you get Love version 092. Yes. And the good thing is, you know, it also has a wiki, which has information about all of the functions that this provides you, that you have to use, that you can use. Let's zoom in a bit. And this tells you, this basically gives you an overview of what you can do with this and how you would do this. But I'm just going to show you an example now, and then you can go from there. So like to run it, the easiest way is to just download the Love and put it in a folder like this. And then if you open up your command window from here, you can just use the Love command. Let's see, Love, and this should run it. And now, right now, it will say no game because we're not running any game. But if you choose a folder, for example, this game folder, and you run that, so in the command terminal, now it's very tiny. Maybe I should zoom this in a bit. Let's see. Increase the font a bit, like this. Love game, and this will open the folder as a game file. And right now it just says no code to run because the folder is more or less empty. It doesn't contain any proper code. But once we program some, you'll see how it works. So I'm just gonna open this now, and right now if you go to the talk, let's see, yeah, I should go back here. I'm using a bunch of files that I've prepackaged. You can find them here if you want to look at it yourself, to just quickly get us started. And the way it works is that Love2D works in Lua. You have to program in Lua. This is really bright for some reason. I hope it's visible when I program, at least. That's the important part. And if you open a folder as a game file, what it tries to do is to run the main.lua file. So I'm just going to create a new document and call it main.lua. And this is the file that it will run as a code. So let's take a look at it. I'm just going to open it up. I'm just going to, let's see, zoom in a bit. And I'm going to start coding a bit. Now, I'm not going to be doing too much coding. Tomorrow I'll do more in-depth programming. For now, this is just the basics, you know, getting you started stuff. And the important thing, like Lua is a bit different from Java, which I presume is the one you're most familiar with due to the courses they have here at the informatics department. But this one uses Lua. It's a different but somewhat similar language. I'll point out differences along the way, but to make a function, you just you start a function like this, and then you name it. And the way love works, actually right now we have an empty main file. Let's try running that, and this just opens up a blank window. Nothing happens. But what we're going to want to do is to start writing some code. So the way love works is that it requires you to write a few callback functions. It's the following: function love.load. This is a function that will run at the start of your program. Everything you write in there, any programming code you write there, will run when you start up the program. And then function love.update. This is a function that runs all the time. No, and this function will run all the time. So you use it to all the change variables all the time. And then function love.draw. And this is a function you use for the output part, to draw stuff on the screen. When you have these, you basically have the foundation, what you need to make a game in Love2D. And that's one thing I like about Love2D is it's very quick to get started. So for example, now if I just draw a rectangle, what I can do is use love.graphics.rectangle. And this is a function that allows you to draw a rectangle on the screen. Now if you go to the wiki, you can browse everything here, and the graphics is what we're interested in right now, and these are all the functions it allows you to draw with and stuff like that. You can draw lines, you can draw points and circles and other stuff. Right now we're just going to draw a rectangle, so we're going to look at the love.graphics.rectangle function, and this tells us how to use it. So first it requires a draw mode. Now you can look at further into what is that, and this will tell you that okay, it requires a string, which is either fill or line, which defines whether the rectangle that you're drawing, if you should just draw the outline of it or have it completely filled. We're going to draw fill for now, like this. And then it says you need the X position of the rectangle, the Y position, the size of it horizontally, and the size of it vertically. So if we use this will put a rectangle that starts at the point 100 by 100 pixels on the screen, and it has the size 200 by 300 pixels. So if you just save this and then we run this, we're going to see that now we have this rectangle. Important thing to notice is that in most computer graphics, the point 0, 0 of the coordinate system is in the top left up here. So 100 by 100 means 100 pixels to the right here, and 100 pixels down here. And then the size is 200 by 300, I think. And that'll draw a rectangle. But a simple rectangle isn't all that fun. We want to do something more with it. So we can declare some variables here in the load function, which is run at the start. So for example, we declare x equals 100. And love is very, very simple. It doesn't require you to specify int x equals 100 or all that kind of stuff. Just write x equals 100 and that works. And then we're going to replace this one with x. So now the x position of the rectangle is this x variable. Well, right now the x variable is always 100, so if we run this, it's just going to be the same. But for one thing we can do, for example, is to always increase the x value. We can say x equals x plus, and then what speed we want it to move at, which would be, for example, 200 pixels per second is what this means. It's very important to use this dt variable so that you know how much time has passed. And this basically means we're increasing x by 200 pixels per second. So if we save this and run this, what we get is a rectangle that is moving along the screen. Well, and then if we want to do something more with that, we could, for example, say that, okay, instead of the x moving by 200, we're going to check if the player is pressing down buttons to get some input. For example, we say if love.keyboard.isDown, this is a function that checks if a key is pressed down, and we look for the W button, for example. Then, or let's go with the left and right movement only. Then x equals x plus 200 dt. End. And then we also do something similar for moving backwards. If love.keyboard is down a, then x equals x minus 200 dt. And this will be a simple code that for every frame checks if we're holding down right or left, and then moves the cube accordingly. So we're going to just run this, and we'll see that if I let's see, now yeah, if I hold down D, it moves to the right, and if I hold down A, it moves to the left. So now I'm just going to make a quick game, just to show you, how easy it can be to set something up. So I'm going to create a circle that I call player. Player equals, and this is an array essentially. So I'm just going to give it a few values, or a hash map, something like that. In Java, it's called a table in Lua. We say, okay, player x equals 100, for example, y equals 100. So and then an r equals 20. And this is going to be a circle. So you say that, okay, the player has a x and y position of 100, 100, and then a radius of 20. So now I'm going to draw that here. And I'm going to say, okay, log.graphics circle player.x player.y player.r, because the circle and also I forgot fill. The circle requires an draw mode, x position, y position of the circle, and then the radius of the circle. Now they're defined as player.x, player.y, and player.r. Yeah. Are there any questions? This part might be a bit difficult if you aren't too familiar with Lua coding, but this is how you would make a simple object. Now, I might also get into classes and object-oriented programming, but I'm more likely to do that at the end of the presentation or tomorrow. But yeah, for now, we have now player that we're drawing on the screen, and now what I'm going to do is I'm going to say that the player.x, I'm going to change it constantly every frame, equals love.mouse get x. So I'm just going to make the player follow the mouse. Player.y equals love.mouse get y, like this, and let's see if I've done everything right, and I run this. Now I'm getting a circle that is following my mouse all the time. So one thing now, a white circle is kind of boring, so I'm going to change the color. You know, Love allows you to do this very easily. Love.graphics, set color, and I can set it to any color. For example, I want something that is greenish, so 0, 128, 0. Oh. This uses RGB colors, so 0 red, 128 green, and 0 blue. This will be a greenish color, and then I'm going to always find to remember to change the color back to white after everything you do. 0, no, 255, 255, 255. That's a white color. So if I run this, we now have this green dot that is following our mouse. One thing we could do, for example, now that we have that as a mouse, is to disable the mouse button, the mouse, the cursor. Love.mouse, and then I don't remember what it's called, so I'm gonna check it up on the wiki. I go to love.mouse and I try to find, okay, how do you disable showing the cursor, the default cursor, and that would be, let's see, set visible. Set visible, then true or false. Love.mouse.set visible. No. False. There you go. And now my mouse is replaced with this green dot. So next thing I'm going to do is to create one more circle, and that's an enemy. Enemy equals, and it's a circle just like this one. So this one has an x equals, for example, the position can be 500 by 500, and then it has a radius of 100, like this. Oh, I forgot to draw it, and I need to remember to also draw it. Let's see, in function of the draw, I can basically copy this, but instead of green, we're going to use red because it's an enemy and it's dangerous. And then we're going to use enemy dot x, enemy dot y, and enemies, yeah, radius. And now we have this red dot. One last thing I'm going to do now is to actually, I'm going to move the draw order around like this, so that the player appears on top of the enemy. Yep. And now what I'm going to do is to, in the love.update, I'm going to create a simple script that asks, like, I'm going to check if they're overlapping. If the enemy is touching the enemy, if the player is touching the enemy, then he dies. So I'm just going to check now if they are overlapping. And how do you do that? Well, circle-circle interaction works like this. Basically, you ask if the distance between them is less than the combined radius. So if we say, I'm going to create a new function now to make it easier. I'm going to call it function distance, object 1 and object 2. So now I've created a new function that takes two objects and it measures the distance between them. So what it does is return math.square root. This is the function for distance between 2 points. O1 dot I'm just gonna remember to use these. O1 dot x minus O2 dot x object there, and then you multiply that by this again, plus, and then object 1's y value minus object 2's y value, and you multiply this by itself. So this is the function square root of, a squared plus b squared, where a and b here is the difference in x and y coordinates. And this should return to us the distance between the two objects. Okay, so now I'm gonna check here. Is colliding equals if, let's see, distance of player enemy is less than enemy dot r plus player dot r. So I'm checking if the distance between them is less than the combined radius, and this should tell us if they're colliding or not. And this is just a Boolean function, so is colliding will now have false or true in it. Now I'm going to do something with this, let's see, and that is to here set a color, love.graphics set color. Yeah, I'm going to use red, and I'm just going to draw a partially transparent red. I'm just going to draw a rectangle over the entire screen, so the screen gets this red tint if you're hitting the enemy, and that would be 0, 0, and then I can just use love.window get width, love window get height. These are functions that just return the width and the height of the window, and I need to remember to use fill mode. There you go. And this, let's see if this works. Oh, now it's doing something wrong. Let's see.
Set cam.
Oh yeah, I forgot to. The thing I forgot here is to actually check if they're only draw this if they are colliding. So if is colliding, then and then I need to set the color back. Like this. And if this is true, then the color will, then it'll draw this red overlay. So now this is a very simple, kind of like a game. For example, you could extract this and like make it so you have a maze that you have to go through and stuff like that. But this is, you know, a very basic example of a game you can make in 15 minutes, you know, and then with time you can make more and more complex stuff. So like if I were to show more now, next thing I would be showing you is how to use images. So I think I'm going to do that as the last thing. I'm going to use an image in place of the, instead of having a green circle, I'm going to have the player be an image. So just say player, we load this somewhere. I can load this in the here. You can say here, image equals, and then love has a function how to load an image, love.graphics new image, and this you can load a image in your folders. And now I have already prepared an image in graphics player.png, so I'm just going to load that graphics. So now the player has an image file. Now I have to remember to use it. Here in the draw, instead of drawing the player like this, I'm just gonna comment this out, and then I'm gonna write a new code for how to draw the player, and I'm just gonna use love.graphics draw, then player image. The position should be player's X value followed by the Y value. But we're gonna have to do some more stuff to make this work properly. No rotation, and like these are, if you look at the love graphics, see, it's a bit slow. The love.graphics.draw, see here, it's this function, and this draws an image on the screen, and this is the parameters that you need or can use. So we have the drawable, which is the image, and then the X and Y position, and then the rotation, which is 0, And then scale, we need to scale it so that it fits our player sprite. In which case, to scale it properly, we'd have to use player's x value and width, which would be radius, and divide that by the image's radius, if I remember correctly, divided by so player.image, and image files have a get width function, which makes it really easy. So you don't need to know how wide the image is yourself. You can just use this function and get the width. And then we need to scale it in the y direction, which would be player.r divided by player images get height. See? And lastly, one thing to remember when you're drawing images is that it draws it from the top left. We want to draw it from the center, so we need to move the image by half of its width and height. If this is a bit confusing, I can explain it in more detail. Just anytime you have any questions, just feel free to ask. But let me just show you this first, and then we can look at the code more clearly afterwards. No, divided by 2. There we go. Now this should draw the player. Let's see if I've done everything correctly. And oh, the player is really tiny now. And I also forgot that I need to multiply this by 2 because I'm working with diameters, not radiuses. And the diameter is 2 times the radius. So there you go. Now I have this player sprite. And yeah, it's still the same code as before, but this was to show you how you can use this to output graphics. And then if you look more at it, you know, it can also do sound and audio, how to play music, sound effects, anything you'd want really, you can find here.
When drawing something, do you always have to specify all those parameters?
No, of course not. How it works is that some of the parameters are required, and then but they're not all. And this, I think this tells you which ones. No, it doesn't tell you quite which ones are required and which ones aren't. But of course, you need to supply which image to draw, which would be this, and where to draw it, player.x, player.y. And the rest is optional. But the thing is, if we, for example, I'm just gonna comment those out to show you how it would turn out. If we just draw the player.x, player.y, it would turn out like this, which isn't quite what we're looking for. That's why we need to also specify the rotation, which would be, I mean not the rotation, the scale, which is this, to make it the proper size. And the scale in the y direction, you can scale it differently in x and y direction. And then this last thing is so that instead of drawing it from the image from the top left corner, you draw it from the center of the image itself. Any other questions about this? If not, then I will go back to the presentation and talk. I'm going to upload the finished product here. I might work some more on it if we have time after the presentation, so we can do some more. If you have any requests for what you're wondering, for what you want me to code, I can do that as well. But yeah, that was some basic how to use Love2D to make a very, very simple game. Just to show you that, you know, it's actually not that hard. When you look at the code, you know, if I zoom out a bit, see, it's not that many lines of code to make such a simple game. And like these are just not even necessary. This one I comment it up. So like, but of course, if you make a more complex game, you are going to have to use, you know, a lot more code. But generally, it's you know, this code was enough to produce this game. So, you know, it's not that bad actually to make a game. Right? And yeah, again, I'm going to upload the finished code on this slide afterwards. It will be right under here. Sure. However, I mean, we now know that we have these game programming frameworks that we can use to make games with, but you know, it's still not easy to make games. I mean, there are a few steps you have to do before you get good at making games and can, you know, make a good game in just a bunch of days or weeks to make a proper game. And well, here are some tips for how to get good at making games. First off, most importantly, is to practice. The more you code, the better you get at it. The more you make games, you'll just get better and better at making games. And you should definitely start out with small games. Don't be too ambitious with your first game. If you try to make, you know, The Legend of Zelda as your first game, it's not gonna work well. You're just gonna fail epically, and it might like put you off. You're gonna be disappointed and then stop making games. So it's important that you start small, and then like the more you learn, then you can make bigger and bigger games. Start with making some simple games like a runner, or I don't know, a Tetris clone. That Breakout is a very nice game to start out with. Snake, make Snake as your first game. That kind of stuff, you know. Only go over to more difficult games once you are a bit experienced. Another thing to remember is that your first game will be shit. There is no getting around this. You will start out terrible, and that, you know, the first few games might be really bad. But that's okay, you know. Failure just means that you're learning something new, and the more you fail, the more you learn. So you just have to accept that, and then after a while, you just start producing good games all the way. You know, your first game might not run quite correctly, or like the jumping and the mechanics might be awkward, or the graphics show up kind of weird, or your code is unnecessarily complex. That often happens, and you can't navigate through your own code. But you know, as with everything, practice makes perfect. Now, another thing you can do is to just talk and very importantly, like listen to tutorials, all that kind of stuff. You know, tutorials are a very handy way of learning, but generally tutorials are best for specific stuff. If you have like one specific question, you want to find out how do I do this, and you go about and you find a tutorial. For example, one time I needed to make an AI that, you know, could go from one place of the map to the other place and avoid all kinds of obstacles along the way, so it didn't just slide through the rocks. And you know, I just googled it up and I found a tutorial on A-star pathfinding, and this taught me how to, you know, make this specific code that was for making an AI find a path that avoids obstacles. I was just discussing with friends and like partners, programming and like game development. If you're like in a game development team, you can talk with each other and learn a lot of stuff, as well as, you know, discuss it on forums. If you like, Love2D has its own forum, for example. If you're using that, you can look at other people's stuff and, you know, discuss how to make games with them. And studying, and now studying might sound a bit boring, but really what this means is that you should play games. By playing games, you're gonna learn, you know, how they did things, and you can learn a lot from them. Some, you know, basic stuff even I learned from like looking at the code for Super Mario World. That like got me started on a bunch of stuff. It can be really useful. Now, looking at other people's code is a bit questionable. It's not always nice. A lot of people have very, very different ways of programming, and programming isn't something that, if you look at it, you understand what it does immediately. So it might not be very applicable for programming stuff, but in general, you know, stuff for design decisions, how a game should be made, you know, what makes a game fun, that kind of stuff, as well as, you know, graphics, music, that kind of stuff. It can be very useful to look at other people's work and learn from it. And lastly, practice some more and more practice. This is the most important part, you know. No matter how much you listen to tutorials and you watch other people make game and all that kind of stuff, you're just not gonna get good at it unless you practice yourself. Yeah, you won't get anywhere unless you start off. You're gonna start off small and get better, and that's the only way to make good games, really. In the end, this is the #1 important thing. That is most of my talk, pretty much. I have some tips and links at the end here, just to show you some stuff. Program modularly is one thing I put here, which means that you should, code in small chunks. Don't make like what I did here and make the entire game in the update loop. It's okay for a basic game, but as you go on, you want to separate things more and more into like separate functions and classes and that kind of stuff. It's important. Use version control. I suggest very much that you use Git, the Git for keeping track. If you don't know what Git is, well, learn it, because Git is kind of how do I explain it? It allows you to work. Basically, you put your files on a central server somewhere, and whenever you work on your game, you push it to that, and then you load from that, and it keeps track of any changes that have been made to your file, so that if you ever make a mistake, you can roll back to a previous version. It also very usefully allows very easily for many people to work on the same project by having it in uploaded in one central place instead of having it on one of the people's computers. You have it in a central place where both have equal amounts of access to it and stuff like that. Version control is really important, and you should learn how to use Git. And these are just some useful links that I found on how to make your games juicy. Your first games might feel very boring, and this is a way to make games, spice them up, make them feel more interesting very quickly, very easily. There are some links here, useful links, like the pocket knives for game developers. It's a list of all kinds of tools that you might have to use, want to use. And these two links are the GDC Vault and the extra credits. These are links. They are mostly on game design and not necessarily specifically on programming, but there are many talks and presentations on game design philosophy and that kind of stuff. And the most important stuff actually is to have fun making games. If you're not having fun, then you probably shouldn't be doing it unless you're getting paid for it. So it's very important that if at any point you find that you're working on a game and it's just not fun, just stop, make a new game, something like that. After a while, you get more used to it, and then maybe you can force yourself to finish projects that aren't as fun, but really you should be having fun, especially in the beginning phase. It's very important. That is all from me. So now this was a very basic introduction. I didn't go very thoroughly around exactly how to make a game, how to program, from scratch to a moderately sized game. But tomorrow I'm gonna have a talk that is much more detailed on the programming part. How many people are planning to attend that one? I wonder. How many of you? Yeah, very nice. I would definitely recommend it. And of course, are there any questions? Just raise your hands. Yes.
Can you upload your lecture on the internet?
It is already on the internet. This slide, you can find it. Let's see if I go to the first link. Let's see. There you go. This is a link. You can find this presentation on this link, folk.uu.no/srodk/gamedev/intro. And of course, there are some links in the slides, especially here in the beginning, the files in the middle, and the useful links at the end. Just navigate to this page for everything. Any other questions? Yes.
What is the most important thing to think about when you start making your first game?
Again, it's the fact that it's not going to be easy at first. You're going to have a lot of, it's going to be very confusing, and you don't know which functions to use. You don't know, exactly, okay, what is the first thing that I create? The player, the scene, the enemies, what? How do I do it? How do I put everything together? That and the fact that your first games will be bad. Those are the most important things to think of when you start off. That is why I would recommend, starting off by just following a tutorial. That is like, how to make your first game step for step. Every single line of code that you have to write, you just look at that line of code and you write it down exactly as it is, and you make that exact same game as they are doing in the tutorial or presentation or whatever it is. This is what I will be doing tomorrow. I will be make a game, and you can write it down line for line so you can achieve the same result. And this will give you a basic understanding of how to go about making games. So what is the first thing you're going to do? What is the second thing? Which functions are important, and stuff like that. And that is really the most important. Those two things are the most important things. Exactly which steps to take, which functions, what do I make first, what do I make second, and also the fact that your first games will be bad. When you make them on your own, they're gonna be not very good. And your code might be ugly, but that's fine. That's fine. And also, another thing that I didn't mention here that I should probably say, when you're making a game, don't plan too far ahead. One thing I did at the beginning when I made games was to sit down for 2 weeks and just plan every single detail of what is going to be in this game and how it is going to work and stuff like that. But by the end of the 2 weeks, before I had even started making a single line of code, I got tired of the project because it was, I don't know, I had done 2 weeks of just planning and it was very boring. And generally, you're still gonna fail at some level, and you're still gonna have to do more planning as you go along, anyways. So really, as soon as you have the basic ideas, start programming, and then as you get new ideas, add them to the code. Your code isn't going to be as pretty, and you might even have to just rewrite the entire thing at some point. But it really helps. It keeps you motivated to go along, so that for every new idea you have, you're gonna code a bit, and then you have something shiny that you can look at and see, oh my god, I succeeded in making it slightly better. And now, okay, how do I make it even more slightly better? And then you go on step by step. If you just plan everything ahead and then you try to write everything, it's gonna be boring. That's another important thing to remember. Yeah, any more questions?
Are you also going to program in Java?
I'm not going to program in Java tomorrow. I will be using Love2D and Lua because it is my favorite language. I'm not actually very fond of Java myself. Let's see. Yep. But for example, if you look at these two frameworks, both use Java. Processing is very simple. It's okay for new beginners. It doesn't require much setup. You just install the processing library, and then you can start making a game. It's a lot like Love2D, but it's not a very good framework. Feel free to use it for a few projects, but make sure to stop using it as soon as you can because it's not a good framework. And then go over to Libgdx, which is a much better Java library. But it is a bit more, advanced to start off with. It requires a bit of stuff to get it started. I haven't used it myself, so I can't say for sure exactly how it is. But from what I've heard and seen, processing is very fast and to start Java language, but it's not very good. And then Libgdx is a good one, but it's a bit more harder to start off with. So. These just talk a bit about these SDL and SFML, which are these two, both use C, C++. SFML, very importantly, let's see if I go to the page. SFML also has bindings for other languages. Now if I find it, let's see, multi-platform and multi-language. Here, SFML also allows you to program in other languages, I don't know. It has a Java binding as well, and Python binding if you want to use Python. That might be of interest, but primarily it's C and C++, I guess, C++ mostly. So that's a good one. SDL is very, very lightweight. It gives you very little. You have to do most of the stuff yourself. but it was an okay one. It's what I started off with, just to like get the very basics. If you're not going to be here tomorrow, I recommend what's called Lazy Foo's tutorial. Let's see, Lazy Foo's SDL tutorials is just like getting you started with the SDL, how to set it up, how to, you know, write on the screen, how to draw on the screen, all that kind of stuff. It's a basic, you know, setup on how to use SDL to make a game, and this is the tutorial that I started off with, and this is what taught me how to make, you know, the beginning stages of a game. Yeah, this is Unity. You've probably heard about Unity. It's a 3D yeah, framework. It's a lot more higher level. You don't require quite as much programming as these other ones. You know, there's Unreal. There's there are so many frameworks. If you just like search for video game framework, you're probably gonna find a bunch. A list of game engines. Well, you want something like simple, like Phaser is one that I've also used. It's for like to make games for HTML5. You can use Phaser. Unity, I don't know, has like lots of links, like 10 best game engines of this generation according to IGN, somebody on IGN. And this is more for like AAA engines. I don't know. But stuff like Coco 2D is another one. I don't know. There are plenty. And if you like a specific language a lot, like say you're into Ruby, you want to program in Ruby, just search for Ruby video game framework, and then you're gonna find whatever is the best framework for that language, and so on. Yep.
But if you're into Python, don't use Pygame.
Don't use Pygame, no. And the XML binding might not be bad. I don't know. I haven't looked into Python myself. But yeah, I will be coding in Lua tomorrow. I'll draw parallels to Java as I can, and I hope that's fine. Really, it's more about the basics tomorrow. Like, and generally, once you know one language, it's not that hard to move from one language to another and learn other languages. Should be fine. And Lua isn't all that different from Java. In a lot of ways, you find that, you know, to declare a function, you do it, you know, function level, and you don't have the squiggly or curly brackets. You don't have semicolons after lines, that kind of stuff. But you know how to call a function. You just, you know, it's just like calling a function in Java, and yeah, other stuff like that. And you don't define, you don't use ints and you know, string, all that kind of stuff. You just set x equals 100 and yeah. I personally like, because of Love2D, I've come to love Lua a lot. It's probably like my favorite programming language right now to code in. It's very comfortable. One thing that I love about Lua is that it doesn't need to be compiled. You know, so you saw that, you know, starting the game, it's really fast. No compilation required or anything. You just run it. That said, you don't get the compile errors either. You're just gonna get runtime errors. So if I, you know, for example forgot a comma here, it's gonna complain about it. Yeah, and then, you know, instead of compiling it, you just run it, and then it tells you kind of what kind of errors it found and where it found them. And Love2D is generally very good for like quickly getting started, because you know you just write the code, put it in a folder, and you run the folder as a game file using the Love executable, and then that's all you need. Enable to be able to run Love from anywhere, you gotta put it in your path. Like you probably did the same with Java. If you're using Windows, you had to put the Java, you know, development kit in your path. You have to do the same with the love.x to be able to run it from anywhere. Yeah. And yeah, like one thing we can do, for example, is to go to let's see, love2d.org, the webpage, and we go to the forums, and we look at projects and demos. And this is, you know, a lot of stuff that other people have made. For example, Okay, leprechaun versus bears is a thing that somebody made. You can download the game from here. Just give me the love file. Yeah, I don't need to save it now. Let's see, and then we can run this. A .love file is basically just a zip folder, so and the love can open it. Let's see if I open this. Oh, and it already has an error at the beginning. Good job. Yeah, that's the thing though. This is probably made for an older. The thing about Love 2D is that it updates kind of frequently, and it's still not out with like the initial release. It's still in 0.9. So every so often it just like removes older functions and they don't work anymore. That's kind of something you have to be careful with. But let's see. Maybe this one is a game semi-control. All right, we can look at this. It's a GitHub project. You just have the .love file. That would be the best. Let's see. I don't want. No, I don't want to download. Let's see. It's a bit. Let's see. 30-minute jam. Maybe this one. Oh, here's a Pong game that someone made. See, save and run. Yep. Oh, it's a 2-player Pong game that someone made using Love, and you can find a lot of. Oh well, that it's kind of yes, not ideal. I see. Sometimes works, sometimes not. But you know, he made this game in 30 minutes, so I can't really blame him. Yep. And there are a lot of other games, and also very importantly, there's also a lot of helper libraries. So you know, you want to handle vectors. Love 2D can't. It doesn't have vectors by default, but you know, you just go to the Love 2D. You just search Love 2D vector, and you'll find the like for example this link, and this one sends you to let's see, documentation here. And here you can find a bunch of libraries, and this is a vector class, and you can download this, and then you have vectors, you know, and then you can use them. And vectors are actually very useful. I'm probably gonna use them tomorrow. This library. Yeah. Any more questions? No. All right. I hope you all have show up tomorrow, and that you have fun making games.